Good morning, everybody awake. Welcome to the presentation. Who's familiar with MongoDB? I saw some people yesterday, so I hope you learned something in the workshop. My name is Felix Reichenbach. I'm a solutions architect at MongoDB. And maybe I start with a few words about myself. I'm based in Switzerland, I'm Swiss. And if I'm not in front of my computer playing with technology, I'm really a chocolate guy. I need chocolate. It's what keeps me running, like many other Swiss people too, I would assume. And I really love mountains. So if it's skiing, if it's snowboarding, if it's, paragliding, you will find me doing all kinds of stuff up in the mountains. But you're not here to learn about me. You're here to learn about MongoDB, or if you're not familiar with MongoDB, at least how you can protect your most sensitive data in a database technology. So we have a lot of stuff to cover today. It's actually a new presentation style I'm trying here for the first time, so I'm curious if you like it. And I will start with what has happened with MongoDB so far. So MongoDB is a product which is already, I think it's more than 10 years now on the market, but it has really evolved over the last couple of years. And then I will do a deep dive into why you're actually here, most probably, how you can encrypt the data. And if there's some time in the end, I think so, then I can do a little demo, or if you're interested, come to talk to me at the booth and I'll show you that demo directly to you. One important slide first, safe harbor. This feature, which I'm going to talk about, is still in beta. So we're working hard to get it out GA, but you can actually already use it, play with it, but don't take it into a production environment at the moment. So MongoDB. For those people who are not familiar with MongoDB, MongoDB isn't a niche technology anymore. It's really mature, and you can see that we have already way above 70 million downloads. Technology is widely used, and developers love it. That's why on Stack Overflow, we're actually the most wanted technology. So it's really a technology where people are interested in, people want to use it, people want to learn about it, how to use it. And we think it's the next generation database technology built for the cloud, but you can also run it on-premise in your own data center. And to give you an impression how much MongoDB has evolved over the last couple of years, we can look at the roadmap and we see that we've done a lot with security as well. So we're in the security track, and therefore we introduced in version 3.2 a new storage engine. That was the WireTiger storage engine, which allowed us to encrypt data at rest, which means the database file, the data you store in a file on the file system, is fully encrypted. And we've further enhanced authorization mechanisms with LDAP. We then introduced the latest and greatest encryption mechanisms, and we're now here, and this is what we're going to talk about primarily, came basically to the last step, the last mile of encryption, which is basically encrypting individual fields inside of documents to make sure nobody can access that data, even if they have access to the infrastructure server running MongoDB. And I may start with a little introduction, a little demo. So step one of that demo is we'll insert some data. For those of you not familiar with the MongoDB language, database collection, I want to insert the document with an ID of 1, the name Doris, and the social security number, which is very sensitive data in the US. It's not that, or we don't have such a sensible number in Switzerland, passport ID. Everybody can know it, doesn't really matter. But you can also think about a credit card number. If the term social security number doesn't associate with you very well, just think about credit card numbers. You don't necessarily want people to know your credit card number. So we insert the data. Step 2, we go and we want to find that data. Simple MongoDB query language. In step 3, we print that information out onto the standard out. There we go. So that's actually basically the end of my demo. And hope you like it. So the whole thing with client-side encryption is that it's really bad for demonstrating, because we do the hard work for you. We do everything in the background, and we try to make it as easy as possible to work with the data you're already used to. So what does it, or how does it work? What you see is you have your data in your code or in your application. You want to send it to MongoDB. What arrives on the database server is basically this, with a binary data type, the social security number, securely encrypted. And if you want to retrieve that information, what the driver receives is the binary data. But what you will see, because it's transparently done for you, is the information you were interested in. Pretty straightforward, very simple to use. And you may ask yourself, how does that differ from TLS, encryption at rest, encryption in transit, in flight? I mean, we have all of these features as well. Why do we need client-side encryption on top of it? And maybe let's start with a little analogy or a little story. So if we have a MongoDB cluster database with the disk files, and we don't use anything, somebody can go and do whatever you want to do data, right? I just open command line, connect to the database, and then I can run whatever command I like. So to protect from that, we can enable authentication, authorization. So great. We're protected from that kind of attack. Now, we can do a little more sophisticated attack and snoop on the wire and look at the data which passes by. How can we protect us from that? We enable TLS. Simple, straightforward, natively built into MongoDB. And then, well, what happens if somebody behaves like a man in the middle, fakes your database server? It's not a big problem, it's part of TLS as well. So we're safely protected from that perspective as well. Now, there's still a gap. So if we put the data into the database without encryption, somebody could copy that database file and look straight into the database file and read that data. Has happened. Maybe you know the French guy who has stolen some data, some other DBAs who accessed that data. So to protect from copying a database file or stealing a disk, we can enable encryption at rest. This is done through the storage engine transparently. You just configure the database server to do so. And whenever somebody finds a disk or copies the database file, they can't do anything with it. Now, what about the rogue DBA? There's always people who need access to do things on your database server. Hopefully you trust them. If not, you shouldn't have hired them anyway. But sometimes you have super sensitive data and you don't want your DBAs or admins to get access to data. And this is what we really introduced with client-side field-level encryption in version 4.2, which came out in June this year. It's to protect your data from rogue DBAs or anyone who has actually access to your infrastructure. So it's really about reducing the boundary of where your unencrypted data resides, right? So encryption at rest takes this part out of the equation. Then we have encryption in flight, which means data is still unencrypted in memory in the database. In the file, it's encrypted, but if you read it out of the file, it goes into memory. In memory, it's not encrypted because you want to do some calculations, etc. So anyone who would have access to the memory could theoretically read the data. And if we do field-level encryption, we can then remove that from the equation as well, because on the server side, the data is fully encrypted until it arrives on the driver side, and within the driver, there's functions and libraries which will automatically decrypt or encrypt the data for you. So client-side encryption isn't a replacement for encrypted storage engine, TLS, or authentication authorization. All the best practices or recommendations around encrypting storage, encrypting data in flight, and authentication and authorization still applies. It's really an additional feature to provide another level of security. You can see MongoDB side, all we see there is basically rubbish or encrypted data ciphertext. So the interesting thing is, or some of you may ask yourself, how does that work? Because if the data is encrypted, can I really work with that data? Or do I have to do all the logic on the client side? Now, the good thing is, we can do quite a lot, but there's limitations. And I will go through some of the limitations. So we can do updates easily. It's basically replacing the value, right? You do an update, you want to change the social security number. You basically replace the encrypted value in the database, not a problem at all. Now, aggregations. Aggregations within MongoDB are calculated process on the server side. Now, if we have encrypted data on the server side, it's really hard to do something with the data. So keep that in mind if you think about applying client-side field-level encryption. So I have an example here. If I want to concatenate, for example, the name with a social security number, that will be done on the server side. The server doesn't know about the encryption key, so it cannot unencrypt the data, which means it cannot concatenate the data, because if I just get a string back to the client, I don't know that this is an encrypted file or field value. So that scenario wouldn't work. Now, another thing or a question I have received is, will I be able to find data, encrypted data? Yes, you can do, because we support two modes of encryption, random and deterministic. For those of you who don't know what deterministic encryption is, it's basically taking a piece of data, let's say 1, 2, 3, I encrypt it, I will always get the same encrypted ciphertext, which means I can basically just search for that encrypted ciphertext and match on the encrypted ciphertext, which works perfectly fine. If I go for random, I can encrypt 1, 2, 3 several times, and it will always get a different ciphertext, which means I cannot search for that specific text directly. I would have to do that on the client side. So, simplified, social security number will be converted into ciphertext on the driver side. The ciphertext will be sent to the database server, and it will just do binary comparison with the ciphertext. Oh, yes, matches, good, return it back to the client. And it works in more complicated cases as well. We can do, for example, search for multiple social security numbers at the same time. What basically happens is, on the client side, the data will be converted into ciphertext or encrypted into ciphertext. It will be sent to the database, and we will get back the results. Doesn't work for range-based queries, because there's no really range, right? You have a random set of data, so you can't run random range-based queries, but you can search for specific documents. So why do you want to enable client-side encryption? Because a DBA can drop the database still, can do damage, can harm your system. Well, basically there are two competing reasons. And the reason one is because you may want to store your data in the cloud. Now, you can run your own servers in your private cloud, but usually, or people at the moment are looking into public cloud providers, which means they don't have full control of the infrastructure of the cloud provider. You can even use a managed service like MongoDB Atlas in the cloud, which means there's people who can access the infrastructure components of your database service, can access the database files, do have access to memory. And if you have super sensitive workload, then you want to prohibit these people of getting that data. And with client-side field-level encryption, you can basically do it just the way I showed it. It's only encrypted text within the database boundary. All the encryption and decryption will be done on the driver side on your application server. So maybe it's easier to go with an analogy. So I don't know if this is something which is common here in Slovakia, but a locker. Like, you have a lot of stuff. You want to put it somewhere, your cellar or isn't big enough, and you rent it from somebody. This person, let's call her Doris, you trust her because she has a key to your locker. It's actually her locker, but you're just using it. So You can put your sensitive data, your childhood diary into that locker. You will close it, and it's safe. Now, even if you trust Doris, maybe somebody, like police, shows up and tells Doris to open the locker. And the bad thing is, Doris doesn't even have to tell you that the police forced her to open the locker. Or maybe even the police told her to not tell you that they were granted access to that specific locker. So what can you do? You don't want the police or anyone else being able to read that data. So you put it in a vault. You keep the key. You go back to your locker. You put the vault into the locker. And that's the way it works with MongoDB. You have your data. You encrypt the data. You put the data into MongoDB. You keep the key outside. You shouldn't put the key plain text into the locker as well. It doesn't make sense. And now, even if Doris has access to the locker, she can access the vault. She can remove the vault. She can replace the vault. She can burn the vault, do harm, do damage. But she will never be able to read what's in the vault. And there's another reason. Maybe some of you have worked with GDPR requirements. And there's a famous rule or regulation, which is the right to be forgotten. And the right to be forgotten basically says that anyone can ask a service provider to remove his own personal data. Now, you may think it's easy. I just go to my database, delete Felix Reichenbach, I'm done. Well, it's not that easy, right? There's backups. So what am I going to do with the backups? I cannot restore all the backups, go and delete stuff in the backup. I could. If I do so, it would actually break the rules on how to do backups, because it's not a proper backup anymore. So there's not really a way to delete that data or remove that data out of the backups. So, and further, I have to prove that I've actually deleted the data, which gets even more complicated if you think about all that backups on tape and wherever you store your data. What can you do? If I have encrypted data, I can destroy the key. And if I destroy the key, I cannot decrypt the data anymore, which means the data is lost and forgotten. So that's the workaround, or probably the only solution to accommodate such a requirement in an efficient way. So, a lot of theory, a lot of analogy. How does it work? It's simple. You have a MongoDB client. For those of you who've already worked with MongoDB, most probably know this. And what we've added is these auto-encryption options. And the auto-encryption options define what kind of data will be encrypted when you write data into MongoDB. Now, you don't want the whole document to be encrypted, right? Because there's maybe useful information or non-sensitive information. And encrypting is overhead. So there's always a balance. You have to compromise. You should do what's ever best for your specific use case. So in MongoDB or in the locker, there's non-sensitive data besides your sensitive data. And you can use one key and encrypt all the vaults with one key, or you just go for individual keys. So for every single field, you can use an individual key. For every single document, you can use a specific key. You will get full flexibility on how many keys you want to use. So maybe we decide to encrypt social security number and we have a credit card number. Then we do so. And we keep the rest in plain text, if that's useful for your specific use case. So how do we do it? What's required to do so? Step one, we have to define a JSON schema. Wow, MongoDB and schemas. We have schemas in MongoDB as well. Not everyone knows, because most people appreciate the flexibility. So what is a JSON schema? And a JSON schema is basically a description of what your data looks like in the database. So we have a simple example here. We specify that there's two properties, A and B. Property A, or the field A, must be of a decent type integer, so data type is integer, and it shouldn't go above 10, or mustn't go above 10. And then we have a field B, which must be of the type string, and if I insert or update data, I require that both fields are existent. So this document will work well. If I go for this document, I'll get an exception. Now, for encryption, we've added an additional fields, which is this encrypt option. And in that encrypt option, I can specify the key which I want to use. I can specify the algorithm. I mentioned it already, random or deterministic. And I specify the data type, just like mentioned here, key ID. You can use the universal ID, or you can use a specific name you gave to that key. Algorithm, random or deterministic, and the data type. So I provide that schema into the options, and it's done. But you have to consider that JSON schema was actually thought to be used on the server side, right? So I was talking about client-side encryption, but now I have the schema on the server side. How does that work? So there's two types. There's the encryption schema you use on the client side, and then there's still the JSON schema, which you may are using already to control the way data is stored in MongoDB on the server side. And they both work together. So when you want to encrypt data, you use the client-side schema, which defines which fields you want to encrypt. And on the server side, you can then still use, the way you are doing it today already, use your JSON schema to verify that data is or must be encrypted. So if maybe a client is configured in the wrong way, we'll send unencrypted data to MongoDB. You could then throw an error and say, well, nice try, but we really need that data to be encrypted. And you can protect wrong configurability client to insert data if you require encryption. So it's really a combination of both. The JSON schema server side, the one which we had before, is a fallback plan to protect wrong configured clients to inserting the data. So misconfigured client, even MongoDB, that would still work if you don't have that thing configured. The single source of truth is really the client. The schema you specify on the client side, which will tell which fields will be encrypted with what kind of key. So let's go through the different options. This was option 1. Now we said we start with one key maybe, but then suddenly we decide to have individual keys for individual documents. So we have to find a way to manage all these keys. If you have thousands of customers and you want to have one specific key to be able to delete customer data, you will have 1,000 keys. Where to put these keys? Or how to protect these keys? So if we go back to our analogy, we will basically put these keys into another vault, and we keep the key for that key vault. And so we have protected all of our keys, and we only have to manage one key. We put that vault back into our locker. We keep the key. We're done. So if we think about MongoDB, we basically take the encryption keys, encrypt those keys, and store the keys, the encrypted keys, back into a collection in MongoDB. It doesn't have to be the same MongoDB. It can be a MongoDB cluster somewhere else, on another location, on the same infrastructure. You get full flexibility. So there's the key vault collection, which stores that information. And as I mentioned, it's fully encrypted. So don't get scared. We store the keys inside of MongoDB as well. Yes, but if you have access to the plain key data, there's not much you can do with them. But you can query them. And you need to, because if you want to decrypt data, you will have to go and find the specific key, which is specified in the ciphertext. So, key vault namespace, second option. Then again, I have it in a database. Well, people can destroy it, people can delete it. What happens if we go back to our analogy with Doris takes, removes that key vault? Well, not much. You can't do anything with it. And therefore, we have the option on the client side. It's this key vault client, where you can specify where your key store is located. If it's on the same one, you don't have to use this option. If it's on another MongoDB cluster, you just add another MongoDB client, connection to another MongoDB cluster somewhere else, and that key vault client will then provide you the keys when you want to encrypt or decrypt that data. That was the key vault client. And now the last step is, okay, I mentioned we encrypt the keys, we store them somewhere, but I still have this master key, which grants me access to my vault where my keys are stored, right? Because I need a key to encrypt something, so I still have that key. How can I protect this specific key? There's this famous key management service. So kind of makes sense to use a key management service. And the key management service is basically similar to the key vault key, protecting the keys in the key vault, where KMS protects the keys in MongoDB. Now, the crux is, if I want to decrypt data, I need access to both. So I really need access to MongoDB, and I need access to KMS, because I go to MongoDB, get the encrypted key, send it to KMS, KMS will decrypt the key, send it back to me, and then I'll get the data, and I will go through that data. Okay, I have to accelerate. So Key Vault, KMS providers, we got all the ingredients to do that, right? So what we do now is we go through all the steps, we insert data, we compare the data on the client side with the driver, we get the encryption key, we decrypt the key with KMS, and then we use that decrypted key to encrypt the data. Send it to the insert, and we're done. Now some more details, fine print, encryption algorithm. The encryption algorithm, you can see it here, or that's maybe more familiar, a little bit easier to use. And we can protect against tampering data, which means we would recognize if somebody has changed the data as well. So, one algorithm used in two different ways, deterministic and random. Now, how does it work with random? We have the social security number, and when we encrypt the data, we will use a random seed, which means whenever we insert the data, we'll get different binary values, so we can't search for that data anymore. Now, if we use deterministic, we get the same key, and the only difference basically is that we always use the same seed value, which means we will always get the same result, and we can then just search for the exactly same ciphertext in the database. You can put an index on it, you can go and search for it just like any other field. So, all you do is a search, find, the database server will search for the ciphertext, return it to you, the driver takes it, decrypts it, and presents it to you like you would expect in a normal MongoDB scenario. It only works for binary compatible types. And the reason is, if we apply this query to MongoDB, we would actually get different results, or multiple results. But if we do encryption with this, oops. we would only get one result because we're doing an exact binary match, right? So if we would go with this approach, we would change the semantics, and we don't want to do that. That's why we don't allow it and we actually prohibit it. You will get an error if you try to do so. So what's a ciphertext? It's binary data with a new subtype. And older MongoDB drivers who were not familiar with it will just treat it as black box. To them, it's just binary data. Inside of the ciphertext, we have the algorithm and the key ID. And we have the BSIN type and the actual payload. Padding, just like normal encryption works. And another component we've added is a new top-level class to help you bypass the auto-encryption function, because sometimes you don't want to use auto-encryption. And this top-level class can basically do three things. You configure it through the options which you provide to the MongoDB client, and then you can create data keys. New customer gets inserted, you want a new key for that specific customer. Then you can decrypt specific fields with specific keys, and you can encrypt or decrypt fields with that specific class as well. Because sometimes it's not possible to automatically identify which key you want to use for a certain field. So you really want to bypass automatic encryption, which I mentioned at the beginning. And we have an example for that. Here, we can easily do this kind of query. So we have two options. We know this is a social security number, but this is a passport number. Now, the social security number may be encrypted. The passport number may not be encrypted. And on the server side, it's really hard to figure that out. Or on the client side. So we wouldn't know which key to use. Therefore, we want to specify which key we need to use to search for that specific data. Because in some scenario, I want to search for the passport number, then I don't want to encrypt it, but the field is maybe the same. And there's a few limitations with this. So basically, two rules. If we cannot parse it, or if it is impossible, there's some reason where we just can't do it, we error. So you try, you put the query, and then you just get an exception. Sorry, that's not how it works. Please change your code accordingly. How much time do we have? 3 minutes. Okay. Let me, I'm very slow today. Let me jump to the keys. What does the key look like in MongoDB? As I mentioned, we store the key. We have the universal ID, which is unique for every single key. You have the option to provide a name for the key. And then you have the material. So this is the data you will find if you have access to the key vault collection, but it's encrypted. And the keys are cached locally. So if you take the same key to decrypt or encrypt data, it's in memory, so you can still process this, but it's in memory of your application server. So an example, or an analogy again, we have Doris. Again, she now has learned about that feature, so she wants to use it. She has an idea. She wants to create a micro-blogging site, MongoDB diary. So she decides to create a login page. She decides to create post site. She also decides that she wants to read posts, new posts, and then she must provide some functionality to delete data. Now, she has all the right ingredients. She has MongoDB and she has KMS, like we use it. So she creates a key, specifies the key ID, gets a key ID, creates a login page, specifies the schema, it says, I want the email address and the password to be encrypted. She defines that she wants to use the key 609. And as you want to search for the email ID, you want to find your customer or your customer profile, she decides to use deterministic encryption. And since the password, nobody searches for the password, or shouldn't be able to, so we can use random encryption for the password, so we'll safely protect that password as well in the database. We provide these options, the schema, to the MongoDB client. We created a register function, and all we have to do is to insert that data into MongoDB, and everything else will be done automatically, transparently to the end user. Server side, all of the data is encrypted, nobody can access the data. Now, she creates the create post side. She defines the schema. The schema is date, the title, and the body. She decides she wants to encrypt the body. She uses the key 609 again. She creates the post function, create post function. And then she realizes, okay, delete data. Adds the delete function. Now, how can she accommodate the requirement that she needs to delete individual users, right? Because she's only created one key. So she rethinks about her approach, says, okay, I have to change a few things. I want individual keys for every single user, every single customer. So she changes her register function, adds the options, specifies the user ID to find the key, and then she replaces key ID 609 with the user ID, and decides to delete the key. Pretty simple, pretty straightforward. Now she wants to read the new posts. Now if I access all the posts, I will get a lot of data, right? I want to read 20 posts. It's individual keys for individual documents or for individual customers, which means I would actually have to decrypt 20 posts. It's a big load which suddenly comes to the server. So she decides to redesign it and to limit the data which is returned. So projection is used. She only returns the title and the poster, which means I don't have to encrypt the data. I just keep it on the server. I just take the data which is not sensitive, so I don't have to do the decryption. If I drill deeper, I want to see a specific post, then I will get the encrypted text and I will decrypt that text, so I can do performance optimizations and I can make sure that my application works smooth. So basically we've completed the application. Doris puts the application live. It's a great success. Users are using it more and more and more. So she decides to shard. MongoDB can scale horizontally, so she creates shards in different regions. One of the shards will get into some not very trustful land, where people, I don't know, search for dissidents and do all kinds of nasty stuff. And the users really start to worry. What happens to their data? So she creates a news article, explains the procedure, how the encryption mechanisms work, where she puts the keys to encrypt that data. Users gain trust again, and she successfully completed the scenario. Now we ran out of time, sorry for the demo. Please find me at my booth in the other building where the reception is. So I'm happy to show you a little more details, how it works and how you can use it. And thanks for your attention.